Today, I'm going to show you how I fixed the blue light error on the PAX 3. Here's what it looks like. You power on the device, it starts to heat up, and then the lights start flashing blue before it shuts down. The first time this happened, I got a replacement under warranty, but now that one's failed the same way, and I've got another one on the way. It's great that PAX honors their 10-year warranty, but if you like fixing things and hate the idea of disposable technology, this might be for you. I actually repaired the first one, but it's hard not to destroy the charging pin housing during the teardown. I managed to make a new one from old credit card plastic, and while it worked, I'm now testing a cleaner version made with a 3D printer, and I think the results will be much better. That said, this repair isn't quick or easy. The PAX 3 wasn't designed to be serviced, but it can be done. The part we're going to be replacing is the thermistor located at the bottom of the oven. I'll link the part, the 3D print file, and the site where you can order the printed piece in the description. A thermistor is a thermal resistor. In this case, it's an NTC type, which means resistance drops as temperature rises. It likely plays a key role in regulating or sensing the oven temperature. I can't guarantee that every blue light shutdown is caused by this issue, but the fix worked for me, and I'm testing to see if I can repeat it. I also can't say how long the repair will hold up, although the one I fixed is still working. I don't run the PAX at the highest temperature settings, but even being cautious didn't stop the issue from coming back in this case. Perform this repair at your own risk. I take no responsibility for injury or damage to your device.
All right, so we're ready to get started. First thing we need to do is work on getting this housing out. And the way we're going to do that is with a small drill bit, and you can get it started by hand. And just start to make a pilot hole. You can do that above or below either pin. So once we've got our pilot hole, you can take the Dremel tool here on a low speed and just start to drill. You want to be careful because the battery is behind the housing here, so take it slow. Material is pretty soft, so it shouldn't take too long. And you can kind of feel when you're through and you want to stop at that point. I'm just going to take my pick and see if I can get some purchase and apply a little leverage here. Clips are holding it in pretty tight, so it's not going to be easy to just pry out of there. And even if we have to take it out in pieces, that's okay. You can see that it's held in with tension, and it's not easy to get out. Be real careful here when you're prying. It's really easy to slip and poke yourself. I think I've exposed some of the pin here, and I'm just going to go ahead and retrieve it and put it aside. It's important that we don't lose these pins. It can be kind of fiddly, so be careful handling them. All right, so we'll just put that aside for now. And I'm going to see what if I can pry the rest of this thing out. Looks like it's coming up a little bit. Again, you do want to be careful. It looks like I am messing up the flux cables or what have you that's underneath here, and you want to try and be careful not to damage those where the pins make contact. And it went flying. Watch out for that. Okay, so I'm just going to take the drill here and work on getting these remaining pieces of the housing out. See if I can break them up a little bit. Because right now it seems like they're still kind of clipped in. Still won't come out. There we go. So we can get this last piece out. Slowly but surely. Almost there. Skipping ahead, you can see the little clips there on either side that held the housing in place. And it looks like I scuffed up the finish on the housing with the drill bit, so watch out for that. Here's what's left of the charging pin housing. Make sure you save those pins for later. Now we need to get the device out of the aluminum case. And to do that, we're going to start pressing on the mouthpiece side, get it to pop out over here. There is a rubber gasket on the mouthpiece side, and I decided not to remove it, but might get snagged up a little bit, but it's okay. And start pulling on the oven side. We can start slowly pulling the device out. Do you want to be careful because there are magnets on the oven lid, and then there are magnets by the charging port that can fall out. You don't want to lose those. Just going to keep slowly working it out. And that's the PAX out of the case. So here's a little look inside the PAX in case you're curious. By the way, this isn't a bad time to replace your battery if you need one. These are the clips that hold the charging pin housing in place, and these are the magnets that attach to the charging dock. So our next step is going to be to desolder these 3 connections from the board. That'll free up the oven so we can get to the thermistor. Put some flux down, and probably at about 580 to 600 degrees Fahrenheit. And it did take a while to desolder these connections. Just a little bit at a time. Might go faster if you use a desoldering braid. Okay, so now we have the oven disconnected from the circuit board. We can pull the oven out and away from the rest of the device. Kind of pull on those tabs and pull the oven out. So next we need to remove the insulation from the oven. It's that fiberglass looking stuff. And you can see the thermistor there. And you just want to be careful because it is taped to the oven and you want to try not to damage the flex cables in the process if you can help it. So I cleaned off the oven with alcohol. You can see the thermistor and the serpentine traces on the heating element. Now we're ready to try and desolder the thermistor. We're at about 650 degrees Fahrenheit. You can see it's still not enough to melt the solder on the thermistor. So what I'm going to do is use some chip Quik. I'm going to try and melt it into the solder so I can lower the melting temperature and make it easier to remove. Unfortunately, that was a big mistake, and I ripped up the pad on the other side of the thermistor. So now it's disconnected from the circuit. And if you can help it, just try to hold that thermistor down, do whatever you have to do to not rip the pads off. I would try using tweezers and holding it down. You could even use two soldering irons or um, whatever you need to do. Just don't rip up those pads. So now I need to try and retrieve the pad from the thermistor and see if we can somehow get it remelted, reconnected to the trace. So that'll work. And again, we're using chip Quik. So it looks like I got the pad back in place.
So you can see that the hot air is melting the solder, and I'm just trying to see if I can melt the pad back in place, but ultimately the melting temperature is too low and we need to get that chip quick out of there for our final installation. So I'm just going to use a desoldering braid and get all of the chip quick off of the pad. So full disclosure, the solder paste that I'm using here may not be appropriate for this application, but it's all I had on hand, so I'm decided to use it. And while it works, there might be something better with a higher melting temperature. This stuff that I'm using has lead in it, and it melts at about 360 degrees Fahrenheit. Apparently, higher melt solder pastes often have high lead content, but this device is supposed to be ROHS compliant, which I think means that it's not supposed to have lead in any of the solders as a consumer product thing. But um, you'll have to look more into that. It just means you're going to have to use higher temperatures when you're melting that thermistor into place. That could potentially damage the thermistor during installation. I don't know, but you'll have to look further into that to find out um, what kind of paste has a higher melting temperature that might be more appropriate for this application. So you can kind of see that it was hard to get the pad bonded to the trays. But now that we've got that in place, we're pretty much ready to install the new thermistor. Okay, so I'm just threw down some more solder paste, and we're just going to hit it with heat and slowly work it until it melts into place. So at this point, I thought it was in good shape, but it turns out that the pad that came up was not bonded to the trace. So that means that the circuit was broken and it would not turn on when I put it back together. So I had to come up with another solution to get that pad connected with the trace, and I'll show you that in a minute. So before you put everything back together, it's important to make sure that the oven circuits connected to the thermistor are intact, especially after the pad was disconnected. So the way you do that is by checking the continuity between the pads and the ends of the flex cable where they meet the circuit board. One side of the thermistor should have continuity with just the heater side, labeled H on the board. The other side of the thermistor should have continuity with ground, labeled G, and T, which is for thermistor. In order to get that pad reconnected with the trace, I had to make a jumper wire and just cut open a tiny area of the transparent membrane to expose the trace, and I melted it in. After that, I did the continuity test. Hopefully you didn't rip up the pad like I did, so you won't have to do that. So now we're ready for reassembly, starting with putting the insulation back over the oven. At this point, you might notice that you're having a hard time getting the oven assembly back into the rest of the housing. There's something blocking the tube, and there's a little clip in there that's underneath one of the screws, so you might have to remove that. Now you can resolder the flex cables to the board. Turn it on and make sure it works. So now it's time to install the pogo pins into the 3D printed housings. And to do that, we use the soldering iron, and I'm heating it up to somewhere between 4 and 450 degrees Fahrenheit. I don't want to melt the housings, but you want it hot enough so that you can sink these pins.
So I've installed the new pin housing and it's clipped in, and I'm going to try and see if the device will charge. Unfortunately, it looks like it's not charging, so I'm going to have to pull it out and see if we can sync those pins a little further because I think that they just need to make better contact underneath. I decided to try using the old pin housing that I made from credit card plastic because it seemed to work pretty well. I wanted to make sure that there wasn't some other problem happening. So looking at both of the housings side by side, I could tell that the one that I made before, the pins are sticking out a little bit more and probably making better contact. So that kind of helped me confirm that I need to maybe push these pins through a little more. And there you go. It seems to be charging.
Out of curiosity, I thought I would do a little test to see how hot the outside of the oven gets, the different settings, as this might have some implications as to what kind of solder paste you might want to use for this application. This is one pedal, and it seems to top out at about 190 degrees. So I am skipping the second setting and going to 3 pedals. And it looks like we're topping out at about 300 degrees on the third setting. Unfortunately, I installed the PAX upside down into the casing, and I had one of my charging dock magnets upside down. So I got to take it apart, and we're going to put it back together the right way. So that's it, we're done. It's nice to know that there's a way to unbrick these devices, and I think there's a lot of them out there with this problem. PAX just came out with a completely new design, and I wouldn't hesitate to buy PAX products. The biggest letdown of these devices, in my opinion, is not having a hot swappable battery. The nice thing about this repair is that the pin housing is now removable, so you can open it up again without destroying anything. If I were going to do this repair again, I would do the following. 1. Find a way to remove the old thermistor without ripping up the pads. Hot tweezers or 2 soldering irons maybe. With the chip Quik, you might be able to lower the melting temperature enough to use hot air. 2. Use a more appropriate solder paste with a high melting temperature when installing the new thermistor. 3. It was tough to push the pogo pins far enough through the housing such that it made a solid connection with the contacts below. I might use a file to take the height down on the pin housing. Other than that, the results are great and it looks very close to factory.